Aditya-L1, a solar observatory orchestrated by the Indian Space Research Organization, is set to embark on an extraordinary mission. Positioned at a gravitationally stable point known as Lagrange Point 1, situated approximately 1.5 million kilometers from Earth, this spacecraft will undertake a meticulous examination of our nearest star, the Sun. The name Aditya originates from Sanskrit, signifying the sun, and the L1 designation represents its unique location. Aditya-L1 will maintain a safe distance from the Sun, covering a mere 1% of the vast expanse between Earth and the Sun. This prolonged mission, expected to span approximately 5.2 years, grants the spacecraft an uninterrupted view of the Sun, free from the interference of eclipses or occultations. Aditya-L1 is primed to delve into a multitude of solar phenomena, scrutinizing the Sun's atmosphere, the corona, and its surface, known as the photosphere. Its mission is to unlock enigmatic solar mysteries, including the reason behind the corona's significantly higher temperature compared to the photosphere, despite being located about 1,609 kilometers farther from the Sun's core, where nuclear fusion generates immense heat. Moreover, Aditya-L1's proximity to Earth enables the investigation of our planet's magnetic field, the magnetosphere, and how it reacts to charged particles emanating from the Sun in the form of solar winds and coronal mass ejections. The mission also encompasses the study of the space environment around Lagrange Point 1. Aditya-L1 started its remarkable journey from the Satish Dhawan Space Center in India on September 2, 2023. Riding atop a polar satellite launch vehicle, it entered low Earth orbit 63 minutes after launch as planned. Subsequently, a trans-Lagrangian 1 insertion maneuver initiated the voyage to L1, a journey anticipated to span around 110 days, involving 5 additional maneuvers to attain the requisite velocity for reaching this gravitational haven. Upon reaching Lagrange Point 1, Aditya-L1 will conduct a crucial maneuver to establish an orbit. This orbit, formed approximately 127 days after launch, will exhibit an irregular shape, lying in a plane nearly perpendicular to the line connecting the Sun and Earth, as defined by ISRO. The successful launch of Aditya-L1 signifies the culmination of over 15 years of meticulous planning. The mission's inception traces back to January 2008, when it was conceived as a compact 400-kilogram satellite meant for low Earth orbit. Over the course of a decade and a half, the mission underwent a substantial evolution, prompting the renaming to Aditya-L1 in July 2019 to encompass its expanded scope and ambition. The Aditya-L1 spacecraft's top deck hosts a remarkable payload comprising 7 distinct scientific instruments, collectively weighing approximately 244 kilograms. These instruments, each with a unique purpose, are integral to the mission's scientific objectives. Let's look at these instruments and their functions. 1. Magnetometer, MAG. Positioned on a boom extending from the sun-facing side of Aditya-L1, MAG, developed by the Laboratory for Electro-Optic Systems, LEOS, is designed to gauge the magnitude and direction of the interplanetary magnetic field around Earth. It also monitors events like coronal mass ejections, CMEs, and the impact of these events on the surrounding space environment. Additionally, MAG is equipped to detect waves in solar plasma at Lagrange Point 1. 2. Visible Emission Line Coronagraph, VLC. VLC specializes in observing the solar corona, particularly near the Sun's limb. Its functions include measuring coronal magnetic fields and identifying CMEs and coronal loops, outflows of plasma emerging from the Sun's upper atmosphere. The primary aim is to unravel the mystery of why the corona is heated to temperatures significantly higher than the underlying photosphere. 3. High-energy L1 Orbiting X-ray Spectrometer, HEL1-OS. HEL1-OS concentrates on the study of solar flares, electromagnetic radiation outbursts from the Sun. It examines both thermal and non-thermal emissions associated with evolving solar flares, shedding light on the mechanisms behind particle acceleration, such as electrons, around the Sun. 4. Solar Ultraviolet Imaging Telescope, SUIT. Developed by the Inter-University for Astronomy and Astrophysics, SUIT is an ultraviolet telescope with the primary objective of imaging the solar disk. It aims to unravel the pathways through which energy is transferred from the photosphere to the corona. Furthermore, SUIT investigates the wavelengths at which solar flares emit the most energy and how different phases of flares manifest at distinct layers of the Sun's atmosphere. 5. Solar Low Energy X-ray Spectrometer, SOLEX. SOLEX is tasked with measuring the flux of X-rays emitted by the Sun at Lagrange Point 1. This instrument endeavors to uncover the underlying mechanisms driving the heating of the solar corona. It also scrutinizes the dynamics of solar flares, encompassing a range from the most powerful X-class flares to lower-power sub-A-class flares. 6. Aditya Solar Wind Particle Experiment ASPEX. ASPEX is dedicated to making measurements of the solar wind, a continuous flow of charged particles originating from the Sun at Lagrange Point 1. Its mission includes an exploration of the sources of solar wind particles and characterizing events responsible for accelerating these particles. 7. Plasma Analyzer Package for Aditya-Papa. PAPA is equipped with 2 sensors to examine the composition of the solar wind and the distribution of energy within it. It explores parameters such as electron speed in the solar wind and temperature differences between electrons and protons at various points within the stream of solar plasma. These measurements yield crucial insights into the dynamic properties of the solar wind. On October 8, 2023, ISRO announced that the spacecraft is healthy and on its way to Sun-Earth L1. So far, Aditya-L1 is continuing its mission successfully, and we are hopefully waiting for new updates and getting more and more excited to hear about India's new successes in space. It would be interesting to hear about your opinions about the mission. Please share them with us in the comments.